नमस्कार मित्रांनो, तुमचं स्वागत आहे मराठी AIML या चॅनलवरती. मी आशा करतो तुम्ही सर्वजण आहात त्या ठिकाणी अत्यंत छान आणि सुंदर असाल. If you miss my previous lecture where I have explained the difference between the stratified split and the random split, okay, then please go and watch it before you start viewing this lecture. Okay, so today we are going to understand. Now we have the data, we have the train data, we have the test data. Now we try to visualize those data and try to discover the insight from that data. We will also look into that what is the relationship between my target data, which is a housing value, and the attributes I have like latitude, longitude, population, then household, number of rooms, number of bedrooms, etc. Okay, we'll see one by one. Okay, now okay, as I mentioned, this is what today is the agenda. Now I don't have much more in the PPT. Let's check it out our notebook. Okay, so before I already run this notebook last time, so let's go through in 1 minute revision. So this is importing of few specific library which will require. Then this is I am importing the GitHub repository. Here I have written a function to fetch the data from the GitHub. Here I run that particular function so that I get the data and specific library is available here. Sorry, specific data set is available here. Okay, then after that I have fetched the data, then I wanted to read those data, so for that I have executed this function. It is using the pandas library. I have run this library this block of code so that I can see the data. Now I can see here is my data: latitude, longitude, housing median age, total rooms, total bedrooms, population, and so on. Okay, I'm not going to repeat many things as I already explained. Okay, let me jump to the require code so that okay, here is the visualization. Let me run this because matplotlib library I require when we visualize. So to avoid that error, I run this block of code. So this is the code where I have explained last lecture to how we can divide our data into the train and test split. Okay, this is called as a random splitting. Okay, after that, this is something we have executed yesterday where someone has told me that the income has a larger impact on the prediction of the housing value. We will see how it is it really verbally correct or actually it is correct or not. When we see the correlation, I will explain there. So here what I did, I just divide my income into the categories of range of category like 0 to $1,500, $1,500 to $300, and so on so forth. Here I'm just looking at the histogram. Let me execute the code. Yeah, the code is done here, and this is second I have explained about the stratified split. So stratified split means as per our income category we divide our data into the train and test split. For that I have used stratified shuffle split, and this way we are executed our data into the strat train set and strat test set. I'm not repeating again, please go and watch the video and don't forget to like, share and subscribe. Okay, now jumping into that, we have already developed one category, that category called as a income category. Okay, why I have made that income category? To just to divide our data into the train and test split. Okay, for that based on our income category, so that's why I have created the new feature called as a income category. Now I don't want that income category because this was only developed for the categorization purpose, splitting purpose. Now I have to remove that features, right? So for that I use for loop, for set. Okay, in from where I have to remove from my train test. Okay, so which strat train, yes, it coming, and then strat test, yeah, it's come, and I have used the method called as a drop. Okay, set drop, and I have to give the category. What I have to drop? Income category, right? So income category, and I will use axis equal to 1. So axis 1, that means it will remove all the column when I mention x is 0, it will remove the row wise deletion, but I have to remove whole the column, right? Whole column. So that's why I have mentioned x is equal to 1, and in place 2, when I mention in place 2, it means it will make the changes in the existing data set only. So what is my existing data set? Train test, strat, train set, and strat test set. So it will do the modification existing. Okay, so that's why I mentioned in place is equal to, and then I execute it. Okay, so this way let's check is it really did a modification or not. So I mention head here and see it is removed or not. See, now I can see longitude, latitude, housing median, and there is no income category here. So it's dropped from the my test data set and train data set. Now my today's agenda to do the visualization, because right, so let's write it down. Visualize the data. Okay, now to visualize the data, it is very important, guys. You should not touch your original data set, because see, visualization is for our understanding, to get the insight. We are machine learning algorithm is not going to do anything with the visualization. So just to avoid any modification in our train set, okay, we are copying our train set into the one of the variable data frame. And one more important, guys, that about the test set, so you must not do the any kind of visualization in original data set. Our original data set is a housing data set. From housing, let me just take the pen and then explain so that it will be easy. So our original data set is a housing. Okay, our housing we have divided into the train and test. Okay, and now we keep this test aside. You should not touch any kind of manipulation or visualization, otherwise it is a probability that your ML model seen the test set and it will not give the, it will give the false result, false accuracy. So now you keep this test set away. Now we have the train set, right? Now our next target is to do the visualization on this train set, but to have any kind of modification, to avoid any kind of modification, we will take a copy of train set in some of the variable, let's say housing train, and we'll do the visualization and get the insight from that. This is what our next target. Let me delete the drawing. Yeah, it's done. Okay, now for that we have function call as a copy. Okay, so let me copy this my train set here. I'll take a copy and I will save this data into the call as housing train. Housing train is my variable name. So this way I'll copy my whole data set into the copy. Let's see if it is a copy or not. So for that I use again head and see, yeah, it will copy all my data into the housing train. Now we are ready to do some kind of visualization. Now the very basic visualization is start with the scatter plot. Now we know that this is something we are doing a linear regression. I mean to say we are doing a, this is a regression problem. We are predicting the some value, so it is a regression problem. And to have this regression problem, we always use first as a scatter plot and see how the data is scattered. So I'm using this housing train here. I'll use pandas method call as plot. Okay, and what kind of graph I want, so for that I use kind call as a scatter. Okay, so scatter, my x-axis will be the, I use x-axis will be my longitude. Okay, yeah, it's longi is coming, yeah, it's longitude, and my y value become a latitude. Yeah, it's done. Okay, and let's try to run it. Yeah, now you can see longitude and latitude is nothing but the your map. Okay, and this map is about the California. We know that we have the California data as per their district. Okay, and this is a California. I'll show you the actual map, which is I copied from Google. One second. Yeah, here it is. So if you look at the California map, okay, it is more same like this. See, it is more same like this. correct? It is a more same like this. So it is saying that, so we are correct, whatever data we have for the California is almost similar to the actual map which we have about the California. But when you look at this California data, which we, let me just now take this screen here. Yeah, now whatever, no, so whatever stuff we have in the California as a map here, it doesn't give any clearance, right? Means it's just a map and we confirm that. So what first confirmation we got that the data we have about the location is almost similar to the actual. This confirmation we got from this graph, but it doesn't give any further clearance. So for that I will use one more parameter called as alpha. Okay, so I'll mention my alpha value as a 0.1. now see guys, let's wait to exit. See, now it is giving something, some kind of information. When I mention alpha 0.1, now you can see the density, and we see that the density, let me take pen. Yeah, if you can see the density in this area is high. A density in this area is high as compared to other. So what alpha gives us? Alpha gives us some kind of transparency. It gives it gives the more weightage to the where the density is high, and it fade it out those color where density is low. So you can use alpha parameter accordingly. You can set as per your requirement, but I set 0.1 so to get the more insight here. So density in this area is high and density in this area is high, and this is a coastal region, guys. So the second intuition we get that density near the cluster area, that is population density, is very high as compared to density in other area. Now just to take a name of those area, let me show you the graph again, the map which I have downloaded from, 1 second. Yeah, here it is. So if you look at that, the map here again, so density, so this area something like this area in my map, and I think by looking at the graph also we can understood that yes, really density is very high here. Even density in this area is very high. Okay, this is a population density I meant to say. And if you look at the name, it's a Los Angeles, and we used to heard this name many times in the internet about LA. So definitely people living in this riverside LA is very high as compared to this. Okay, because this area is a riverside area, and there is almost economical growth near the riverside area is high as compared to the other side, because of transportation and other kind of development. I hope so. Till now we got the second analysis that population density is very high near the coastal area. So let me write down here second analysis what we got from here. Let me minimize this. So second analysis we got from this, population is very high near a coastal area. Okay, so this is the second visualization we got. Right, next now let us try to observe how is the price. Okay, how the price is vary based on this density. Now we got the population density. Now let's see whether wherever the population density high, how is the pricing is varies. Okay, is it something any relation that wherever population density is less, my housing value is less, or wherever my population density is high, my median house value is high? So let us try to understand this from the graph. So again for this also I'm using this graph only. Okay, so not wasting time in writing same code. And here what I'm going to write, I'll just increase this alpha value to 0.4. you will come to know why I have increased, but let's increase, and I'll mention ES value here. My ES value is a categorical value, and here I mention my housing trend. Okay, so I want to see the population. Okay, and this population must be vary. Okay, wherever population is high, their circle is must be high. So I'm taking my housing trend as a population, it is coming, yeah, population, and I divide this population by 100. Why I'm dividing this value by 100? The reason is very simple. I want to do the scale down. Okay, otherwise I'll write it down, that it is not possible to visualize in a graph. To scale it down means, one means whenever there is a one circle, radius of one circle means 100 population. Whenever there is a radius of two circle, okay, it means whenever the circle has a radius 2 means 200 population. Just to scale it down, I divided by 100 and I'll give that label as a population. Okay, and then I'll mention the figure size of this as a figure size of 10,7. So here what I'm trying to do, I have the map. Here I'm also taking out the population, okay, with the size, figure size 10,7, but I haven't mentioned anything about the pricing, okay, pricing of the house. So for that I use C as a count, okay, and I mention median house value, okay, and then I'll use the default C map as a structure, plt dot get cmap. You can use anything, but this is a what the good it will give. And I have to use the color bar here. So color bar is equal to true. Okay, color bar is equal to 2. Let me execute this and then probably I will explain. Let's take the okay. Now here is the graph. Now if you look at the, let me take pencil. Okay, now if you look at see what is the meaning of this block of code, let me explain. So this is first line, I think you guys are aware. I'm drawing the map here with the first line. Second line, what I'm trying to say, that I'm giving the population in terms of circle. So wherever you form the circle, wherever you find the circle, this circle is nothing but the population, and the radius of the circle is varies as per the population. Now if you look at this circle here, see this circle is a very bigger, okay, circle you find wherever you find circle over here. Now these circles are overlapping each other, so you do not find the exactly the radius of the circle, but the radius of the circle in this area is very high as compared to this north region area. Okay, and after that this third line I'm giving the color. Okay, I'm giving the color. So if you see my color side bar here, the housing value which is near about 10,000 has the blue color, and housing value which is all on the higher side having the red value, and housing size which is near about the middle having the yellow and some kind of green color. So by looking at the graph, I found that yes, wherever population density is high, my housing price is very high, and these are very popular city in the California, guys. So that's why the housing price is also very high. So this is again double check what I have done my intuition, and this is double check from the graph. Yes, I agree. So what is the conclusion? Let me delete. Yeah, so what is the conclusion from here, guys? That housing price is very much high as per density and near the coastal area. Okay, now there is one more analysis. If you look at this graph, so you can find that when you go on the north side, these are in which color? Blue color. So blue color means the price of the house is near about 10,000 or below that. So when you go the north side into north region, that means your latitude is increasing, your pricing value gets decreasing. So this is my second analysis. So let me write down here: pricing of the house decreasing when we move towards north. So this is, guys, my second analysis. I hope you understand what is this stuff. Okay, now so from the graph we understand three stuff, guys. Let me delete this. So these are the three analysis we got from visualization. The first one is that let me go here. The first is that data we have about the location. First, that whatever data we have about latitude and longitude is equal to the actual one. Then we find from the second visualization that population is very high near the coastal area. Third, we find that the price of the house is very high near the coastal and density area, and price of the housing is decreasing when we move towards the north side. That means whenever the latitude is very high. So these are the three analysis we got from the visualization. Now let's move to the correlation parts. Okay, so now our next topic is to understand the correlation. Understand the correlation. Okay, now to as we have very less data, so we can use the Pearson correlation. Okay, and to use the Pearson correlation, we have the method, we have the function in the Python called as a CORR. So when you, and let me save this into the correlation matrix. Okay, so when you execute this, it will give the correlation stuff. Okay, now before moving to that correlation, let me open my PPT and explain what is a Pearson correlation. Okay, before going into the see the actual result. Okay, let me, yeah, here it is my slide. Let me zoom in. So guys, let me take the pen here. Yeah, so Pearson correlation coefficient is actually, it is very helping us to find out the relation between the two attributes. And what is our agenda here? To find out the relation between the housing median house price value against the all other available value, that is latitude, longitude, income of the house, income of the person, total number of bedrooms and rooms. So this is the formula. How to calculate Pearson correlation coefficient? It is very simple, guys. You just have to first calculate the mean of your x and mean of y. Y your is target variable, x is your independent variable. Okay, so x is the your actual attributes and y is your the target variable. So first calculate the mean of that and subtract each value from the mean. Similarly, subtract the target value from the mean and take the summation. Okay, similarly you are following here, but here you are taking the squaring of this stuff and take the square root, and once you did this manipulation, you will get the Pearson correlation coefficient. Now it is very important that Pearson correlation coefficient value is lies between -1 to 1. So -1, whenever there is a value is near about the -1 means it has a negative correlation, and when it is a near to +1 means it has a positive correlation. Now when I say positive correlation means whenever your x is increasing, your y is also increasing. So like this. Okay, but negative correlation means what? Your x is increasing but y is decreasing. So this is called as a negative correlation, this is called as a positive correlation. I hope you understand, and you can calculate this using this mathematical formula. It is very simple to understand, so I'm not going in depth. If you want, you can do it manually. Okay, so this is about the Pearson correlation, and always remember it values lies between -1 to 1. Okay, now let's move to our notebook. Now I want to find out the correlation coefficient, okay, that whatever Pearson correlation with respect to my housing median price value, right? So for that I will use something called matrix. Okay, matrix. Okay, one second. So I have to calculate the correlation matrix. Okay, from the housing value towards the other stuff. Okay, how my housing value is related to the other. So for that I use core matrix. Okay, with the name of the column is median house values. Okay, yeah, median house values, and I'm doing the sorting by descending order. So sorting values. So this is again a method from Panda, and I mention descending order, so I mention ascending is equal to false. Okay, so let's look at the sort values. I missed something. Yes, yeah, it's ascending. Okay, I think I write wrong spelling here. Ascending. Let me, yeah, ascending equal to false. Yeah, so it's good. So if you look at the, let me take the pen. Okay, if you look at the, this is my target. Okay, so definitely it will come as a 1, and I have to find out the relation of my target column with respect to other. Now if you see, the median income has a 0.68. so as I mentioned, your coefficient correlation must fall -1 to +1. Now my median income is positive, my total room is positive, my housing median is H positive, household is positive, and total bedrooms is positive, but my median income is more close to +1. It is more close to +1. So I can say that my median income has a stronger relation with the median house value as compared to other. And if you look at the values, it's 0.13, 0.11, 0.6 and 0.4, which is very far away from the your, okay, which is very far from your +1, right, which is very from the +1 if you take the scale of 0 to 1, right. So that's why I can see that, yeah, median income has a stronger relation with median house value, and we got our so whoever have suggested earlier, I think this gives the proof here. Now if you look at the negative stuff, I can find that my latitude has a negative relationship. My latitude has a negative relationship with my median house value. So when I say negative relationship, means when my x is increasing, my y is decreasing, right. When my x is increasing, my y is decreasing, and same I think we have seen above. So what is my latitude? Latitude is nothing but the, so when latitude is increasing, my housing price value is also decreasing, that we have seen earlier in the graph. Okay, so this is what we understand from the correlation matrix. Okay, so just to write down, I can say that in comment, my housing value increases when income increases, and housing value increases when latitude decreases. Okay, or in, I think this is very scientific way to write, but I can say that the pricing house is low in the north direction, in north area, and north area latitude is high. So these are the two attributes we understood that it has a highly impact. Okay, now just to draw the exact that particular relationship with the median housing, we can again use the scatter plot, and to use the scatter plot we use housing train dot plot, and we use, okay, let me use this. Okay, it's okay, I can use this. Okay, so kind is a scatter. My x value is what? My x value is the house income value. So what is the, let me copy just to avoid the spelling mistake. My x value will be median income, and my y will be the median house value, just to visualize the relationship. Yeah, let me mention alpha as a equal to 0.1 just to fade it out this bit. Yeah, now you can see that here, see my median, so this is a linear relationship, right. My income is increasing, my house value is also increasing. So this when my median income is 4, my house value is something around $2 lakh. When it is 10, my house value is something around $5 lakh. So this also, scatter plot also gives the relation, linear relation, and it is again positive relations. So I hope you understand. Let me explain the last topic about the Pearson correlation. Okay, then we will tomorrow in next lecture we will see some pre-processing stuff that require. Okay, so next slide. Let me enter the slideshow and delete this. Okay, so this is, I again copied from the Wikipedia. Don't worry, I will give the link in the YouTube video in the description, but I want to explain one stuff here, that see, uh, Pearson correlation always falls -1 to 1. You understood that, but how you can, what this number actually it explicit, okay, what actually this value explain? You know, we understand the one is strong relation, positive one is strong relation, and -1 is a negative relation. But when the varies between 0.8, 0.4, -0, what that number, so it actually gives the strength. Okay, positive and negative gives the direction. When it is positive, it's directly proportional. When it is negative, is irreversibly proportion. Okay, but number specifies the strength, how they are morely correlated. Now when I have 1, then the variance between the two data, let's say this is my x data and this is my y data, so they are, when the 1, so they are very tightly coupled and they have very strong relation. If you, when I see it's a 0.8, okay, 0.8, okay, here variance is high as compared to the previous one, so correlation is also less. If you look at the diagram 3, variance is very high. When I say variance, means spread of the data between x and y is very high, therefore their correlation is getting decreased, but still they are positive. Similarly, when we saw our median income, our value correlation is something 0.6. so when it is 0.6 means something coming in between, so variance is very high, but yeah, they are strong relation. How they are tightly related is defined by the variance. If variance is high, then their correlation coefficient is less. If variance is less, then they are highly correlated. Okay, so this is what they want to explain in this diagram. And in the middle diagram, all are the linearly correlated, and these are the not a linearly correlated, therefore their Pearson correlation value is become 0. They are not, see, this form something W structure, this form square structure, this form something called as half moon, you know. Okay, and likewise, so there is no relation and therefore value is 0. If you look at this central diagram, okay, here also your Pearson correlation is 0. Why? Because first the variance is very high, and second, we cannot predict the exact relation, right? Exact relation. See, whenever the x is less, it might be your y is less, it might be your y is high. Whenever x is high, there might be a chance of your y is less or y is high. So you will not able to predict the exact relation, okay, when variance is high. So this falls in here. So this is what I want to explain with the help of this diagram. I hope you understand what is Pearson correlation coefficient. Okay, so I hope you like my lecture explanation about this. So till now we understand what is the visualization, how the visualization helps to get the insight, and how the correlation, Panda's correlation, that is Pearson correlation, help us to identify the relation between your target variable and the source variable. Okay, I hope guys you like my, all the best, and don't forget to like, share and subscribe. Okay, thank you.